Hi there. Today we are going to discuss exponential and logarithmic functions a little bit more than we did last time. And I want to show you how to graph an exponential function and then how to graph its inverse, the logarithmic function. So let's start out here with y equals 2 to the x, or f of x equals 2 to the x. And then we are going to also do y equals log base 2 of x. And we'll see how those are related. Now notice when I write the log, I write that base as a subscript, very important. And then the argument, the x, can be in parentheses or not. So over here to the exponential function, I always like to start out with an xy table. And we know that since the base is greater than 1, we can already do a little preview sketch. We know that is exponential growth. And I recall that every exponential function approaches this asymptote, y equals 0, a horizontal asymptote, and every exponential function always goes through the y-intercept of 0, 1. So before I even make my graph, I already know what it looks like. But now I'm going to do some specific or precise points. Now, as always, we're going to start with 0 and a few positive numbers and then a few negative numbers. We shouldn't need so many because we already know the shape. Okay, so let's try these. So I have 2 to the 0, which we know is 1. And that's right. Every exponential function goes through 0, 1. We already knew that. Okay, so that's kind of a good check. And then we have 2 to the first is 2. 2 to the second is 4. And then 2 to the negative 1. Remember, if you're upstairs feeling negative, come downstairs to get positive. And so we get 1/2. Similarly, 2 to the negative 2 is 1 over 2 to the positive 2, which is 1/4. Let's see here, we can just make a quick graph here, plotting those points. And so I have 0, 1, and then I have 1, 2, and we have a 2 and a 4. Like so. And then I have a negative 1 and a little 1/2, and then a negative 2 and an even smaller 1/4. And you see that those values are going to get really close to the x-axis, but they will never ever touch it. You will never get down to 0. And then we just connect. Okay, and then you can label that horizontal asymptote. Awesome. So that is all there is to graphing that exponential growth function. Now for the logarithm, it's super easy if you have the exponential. So we have y equals log base 2 of x. And then we're going to just simply switch our x's and y's because we remember that it is the inverse. And so I get, instead of 0, 1, I get 1, 0. So every log function goes through 1, 0. Okay? And then instead of 1, 2, I get a 2, 1. So I'm just kind of plotting those as I see them. And then we also get, instead of 2, 4, we get a 4, 2. And I think you see I'm running off of my graph here. I should have made it smaller. Okay, so I get a 4 and a 2 way over there. And then also I get, let's see, instead of negative 1, 1/2, I get 1/2 negative 1. And so that's going to fall right in here. And then we also have 1/4 negative 2. And so we squeeze that in there. And then when we connect, okay, we'll put the arrows on. We should also draw in our vertical asymptote. And so this is x equals 0 is a vertical asymptote. And so that's just a good thing to notice. Instead of y equals 0, we have x equals 0. Okay, and then instead of our ordered pair 0, 1 as our y-intercept, now we have 1, 0 as our x-intercept. And so that is how you graph a logarithm. You graph the exponential function, you switch the x's and y's, you draw the logarithmic function, and then you put in the asymptote. All right, hope that makes sense for you. Let me know if you have any questions.